Okay, so we've got here 4 identical cones, yeah, and we're given that the height of each of the cones is 60 millimeters, and we're not told what the radius is, but it says here then that Lizzie has been asked to make this cylinder here with these dimensions, so radius 40, height 20, and in order to make the cylinder, it says she uses the cones, yeah, the 4 cones here, she melts the metal down and then recasts it to make this cylinder, so she can make the cylinder from the metal from these cones here. There's no waste left over. She uses all of this metal, okay, when it's melted down. And it says then, of course, calculate the base radius r, okay, using this information. So what I would do here to begin with, I would work out maybe the volume of one of the cones, okay, and then we can multiply it by 4 then, because there's 4 of them. So volume of one cone. Now the formula is 1/3 pi r squared h, okay. So pi r squared h, of course, comes from a cylinder, but a cone is 1/3 of a cylinder. This is given to you in the exam on page 2, okay, but it's useful to just try and remember that there. Now, let's plug in the numbers. Now, because this is non-calculator, I'd keep that as pi, right? Don't use 3.14 in this instance because it's going to get really messy. So keep it as pi, all right? And we'll work in terms of pi throughout. Now, the radius we don't know, so I'm going to leave that as r squared, but I do know the height, which is 60, okay? So I work that out. Now, I've got that there. I can simplify this, okay, because what I can do is I can multiply any order I want, okay? So I could put that 60 at the front if I wanted to, okay, or after the third, and put the pi r squared at the end, okay? So I swap them around. And 1/3 times 60, well, that's 60 divided by 3, which would be 20, yeah? So 60 divided by 3 is 20, so I get 20 pi r squared. So that's one cone, okay? So of course then the volume of 4 cones will be 4 of them. So 4 lots of 20 pi r squared, which is 80 pi r squared. Okay, so that's the metal when you combine them together, when you melt it down, that's the volume of metal that you've got, and it gets recasted then into a cylinder. Okay, so what I can say then, if you think about it, is that the volume of the cylinder will equal to 80 pi r squared. Okay, it's got to equal the volume of those cones. And the good thing as well that then I know the formula for a volume of cylinder is pi r squared h. Okay, so I can put those numbers in here. Okay, so I've got pi, remember leave it in terms of pi. The radius for my cylinder is 40, so 40 squared. Okay, and the height of the cylinder is 20. And I know then that's got to equal to 80 pi r squared. Okay. Now, I can work this out, can't I? Okay, I can do some calculations here, because if you think about it, you're multiplying them together. And you can multiply them together without a calculator. You just do 4 times 4 is 16, times 2 is 32, okay? So I just multiplied these values here, yeah? 4 times 4 is 16, times 2 is 32. Don't forget then, of course, you add the zeros on, and there's 3 zeros, so that'd be 32,000, okay? Now, you're left with this here, and what I hope you can see now is that there's pi's on both sides. If there's pi's on both sides, you can sort of cancel them out, okay? Right, and that's perfectly fine. You're allowed to do that, right? Both sides are still balanced because you're taking pi away from both sides. So the scales are still balanced there, okay? So we end up having 80 r squared equals 32,000. So maybe I'll write it like this. Now the key next then, of course, is to take that 80 over the other side and divide. The zeros then will cancel. Okay, and then we've got 3,200 divided by 8. Well, 32 divided by 8 is 4. 32 divided by 8 is 4. Add the 2 zeros on, so we get 400. So r squared is 400. To get r, you just need to square root 400. Now, you might not know what that is, but it does come out to be a nice number. And if you think about it, okay, it will be 20, because 20 times 20 is 400. Okay, so r is 20 millimeters.